Good morning, everyone. I'm just in time for another information technology lesson with Thabo. He's coming to learn more about classes, objects, and data flow. After our last lesson together, we've been working through the steps he needs to do in his practical assessment task. We've done quite a bit already. We started with research and analysis in phase 1, where we stated the problem and identified the requirements. And we've gone pretty far in phase 2 already, from program specifications to classes, objects, and data flow.
Sorry I'm a bit late, but I didn't want to miss this lesson.
We said we would continue with classes, objects, and data flow. In the last lesson, we learned how classes and objects store data in object-oriented programming.
I really enjoyed the part about data encapsulation and the differences between private and public members of a class. That will help me a lot.
Well, let's get on with it then. By the end of today's lesson, you should be able to create class diagrams and create simple data flow diagrams. In phase 2, we must use a class diagram to plan the class definition. The easiest way to go about this is to inspect the IPO tables. From them, we can determine what fields are needed for each class and what methods we should have. Let's look at the IPO table for an event where the administrator logs on. We need an object that will be used to allow or deny access to different parts of the program. Remember that a player may try to log on as the administrator. Let's see if you can identify the fields and methods we need in the object. Start with the fields.
The username and password attempts are local variables, not fields in an object. Hang on. I can't see any fields for an object. Is that because they are private fields encapsulated in the object?
Very good, Thabo. What about methods?
I think when the password is checked and when the admin right is checked to see if it's true or false, those must be public methods of the object.
You really have been paying attention. First a procedure and then a function is called. Each must do a particular task. Is there any input we must give or any output we will get? In other words, is there any parameter passing?
Yes. For the check password procedure, we have to pass the attempted password as input, but we don't get any output.
Aha! That's because this method must compare the attempt with the actual password, which must be inside the object.
Hang on. That means there must be a field in the object that stores the administrator's password. I see. The checkIfAdmin function is going to return a value of true or false, so there must be another field hiding in there to store that. It must have been given a value of true if the password was correct, and false if it wasn't.
A real IT detective we have here, and you're quite correct. The object admin will be used throughout the program to control access to certain screens, so it must be created and placed in RAM when the program opens, and destroyed when the program is closed. In other words, removed from RAM. Where will it store the password before the program opens? In the database, the program code, or a text file?
It is not logical to store the admin password in a database table.
Exactly. It's only one data item that would be one field in one record. And you wouldn't store it in the program code, because then the programmer could change it.
And if you store it in a text file, as the actual password, anyone can access it with Notepad.
There's only one solution. An object can provide a means of encoding and decoding the password using methods.
Of course! If an encrypted version is stored in a text file, it can be seen but not interpreted. So when the program opens, the password must be read from the text file and decrypted before it is stored. And the coding that says how to encode and decode the password can be stored as private methods in the object. and then it is completely inaccessible.
That's right. To draw up the class diagram, you have to differentiate between private and public fields and methods used. Remember, the private methods can only be used by the object. The public methods act as an interface between the object and an external source or destination of data, for example, a program. The public methods can be used by the programmer who calls the method from some event in the program. For example, a check password method.
I suppose the administrator password and the admin rights would be private fields.
Yes, the encoding and decoding methods should be private. The rest can be public methods. Let's take a look at the class diagram for the admin object to see that. A class diagram will have a number of standard things: a heading with the name of the class, the fields in the top section, which is usually private, and their data types, Boolean and string. This F as the first letter helps to distinguish the fields from the variables that will be used in the coding of the methods. The methods are in the bottom section. First, the private methods. Each method has a name and a type, which is either a procedure or a function. The brackets after the method name show what input is required. Empty brackets show that there is no input. Note, however, that every method must have brackets after the method name. This helps to show that you have not omitted it by mistake. The colon here indicates the data type the method expects the input to be. A colon and data type after the brackets indicates the data type of the output, if any, that the method will return to the calling event in the program or a class method in the object. It also tells us that a function, not a procedure, will be used. The function here will send a single value back to a method in this class, an encrypted password. It's a private method, so it won't send the value to a program. We'll need some methods to provide an interface that a program can use. Those are the public methods. And here are the two we looked at before: check password and check if admin. But where did these others come from? Set password must be called when the program opens and reads the encrypted password, which it passes as a parameter. The set password method will then call the decrypt password method and pass on the encrypted password. That method will decrypt the password and place it in fpassword. When the program closes, it will give the instruction to get password to save it in the text file. Get password will call encrypt password, which will do the encryption and pass the result back to get password, which will then return it to the program. And what is this constructor method going to be used for? A constructor is a special kind of method. It's a bit like a procedure because you define it in the same way you define a procedure, and because it performs a specific task. You can also pass parameters to a constructor. So constructors are defined like a procedure, can only create an object of that class type and set initial values of fields, are called like a function, can only return a reference to the object created stored in a variable of that class type. The programmer can use the name of the object anywhere in his program to refer to the single storage location. Let's look at an example where a constructor is used in a program. Here, the programmer states that my object is of that class type. The programmer then calls the constructor, which creates the object and returns a reference to the object. The programmer can now refer to the object as my object whenever he uses it in the program. A constructor always clears the storage fields in a new object by default. That means all fields start with a value of 0 for number data types, empty or null for string types, or false for Boolean types. So there is no need to give instructions to initialize fields in a constructor, except if you want them to have a particular value. Before I show you an example, tell me, do you think an object gameplay is going to be more complicated or less complicated than an object admin?
Much more complicated. The games involved fetching a whole lot of terms and definitions.
Well, let's see if you're right. Here is a class diagram to show a storage object for one question. One field will store the question and the other will store a number which will be used to find the correct answer.
But how can we only have one question? And where is the answer?
Patience. Look at this constructor. What parameters must the program pass?
Oh, a question and a number.
Correct. So the constructor can place those values in the fields, like this. Notice that the first instruction is to inherit the built-in create method. Our create method will now also be able to create objects, but will give the initial values that we have decided on. Also remember that the data types must match. What about the two functions in the class diagram?
They will send the question and the number of the correct answer in the fields back to the program. But why can't I just send it back in the same function? Because a function can only return one value.
You could convert the integer to a string and send them both back in the same string. But there's a more logical reason. The question is needed when you start the game, but the answer is only needed when you are seeing if the player got the right answer. So the programmer should be able to access them individually.
I still don't see how it helps to have only one question.
What did we learn earlier about when we need multiple data items?
Oh, of course. I'd have to use an array. So we need an array of question objects, and because array elements have numbers, we can use those as our question numbers. We use 10 elements in the array to store our 10 questions for the game.
And each question in the array also has the number of the correct answer stored with it. Where will you store the answers?
I'll use a plain old array for that. An array of strings that can include correct answers and incorrect answers. Let's see. For a multiple choice test, we need one correct answer and maybe 2 incorrect answers. So that's 3 answers per question, equaling 30 elements. So to find the correct answer for a question, we just look up that element number and bingo, there it is.
Well, I think there might be a problem with having both kinds of answer in the same array. You might think about using 2 arrays, but this lesson is about class diagrams. So let's get back on track. Think you could describe every object of your pet in a class diagram? Once you've done that, you are ready to move on to the next step, creating simple data flow diagrams. We use a data flow diagram, or DFD, to show the movement or flow of the data identified in all the IPO tables. It shows what kinds of data will be used as input to and output from the system, where the data will come from and go to, and where the data will be stored. Any idea where data would move or flow in a program?
Between the user giving input and getting output, the events and the files on the hard drive. Same with the storage structures in the RAM.
Data will move between the user interacting with GUI, or graphical user interface components, the events or processes when the CPU is used, the data structures in the RAM, and the files on the hard drive. The program you are going to write will be a system. A system is a group of independent but interrelated elements comprising a unified whole. Every system has system boundaries. The elements of your system are inside these boundaries. All DFDs have 4 components. Here, the entity which gives input is the source. The entity which receives output is the destination. Processes events that occur in the system, and they receive input and deliver output. Data flows shown by one-way or two-way arrows, which can be labeled to name the data items being transferred, and data storage locations, the temporary structures in RAM and permanent files on the hard drive. DFDs are produced in a series of levels using a prepared list of the 4 components. In the PAT, we use the IPO tables as our list. I'll show you the context diagram first. This only shows the system as a single process and the external entities. It doesn't show storage. In this case, the system is a library, shown in the center as a segmented dark blue rectangle. The 0 indicates that processes are not being numbered yet. When the rectangle is used to represent a process in the next levels, the other top segment can be used for naming the process. The 4 sides of the rectangle represent the boundaries of the library system. The data flow arrows outside of the rectangle show the system's relationship with its environment. We only aim to show how the entire system interacts with the outside world, its context. There is no detail yet of what happens inside the system. As a general rule, if a lot of data travels together, it is shown as one concept. Look at this example. Book details. Book is shown inside the arrow because it is a physical object. For the PAT, the files or database tables can be shown this way, but only in later levels. You would show the 2 entities as player and administrator, and you would write the name of your program where it says library. The next diagram, called the level 0 diagram, shows general processes and data storage inside the system. The large white rectangle in the background shows the boundaries of the library system that we saw in the context diagram. Enter the name of the system library as a heading at the top, but not a number, because this is the main system. But you can use a 0 again in the top left segment. Now we are showing the main processes of the system, the main events, like logging on, playing a game, or working with the database tables. Each process should be numbered. Look at how the data flow arrows now cross the system boundaries to connect to only one element inside. If the external entity must be connected to more than one process or event, the entity can be shown repeatedly on any side, including above and below. This is done to avoid too many arrows and crossing arrows. In the places where it says data store, you would write database, text file, or object. If you have more than one, you should write a name as well. For example, player object or admin object. Look at the arrows connected to the data storage locations. Notice that all data stores must receive input and must give output. Data storage names can also be repeated, but each process must only be shown once. Processes can send data to each other. For example, one process may call another to check the validity of data. Look at the process on the right. The arrow shows that it can receive data from the process on the left. It can also receive data from the data store above it, but it can both send and receive data from the data store below it. This would be a good way to show the administrator this external entity on the right, working with the database. We can see that the other entity, the player, has no access to this process. For the next level, we draw a level 1 diagram for each of the major processes in the level 0 diagram, so you can have several level 1 diagrams. The aim of a level 1 diagram is to illustrate any of the more complicated processes and data stores from level 0, so the simple ones can be ignored. The oval represents something inside the process, which is giving input. It is not receiving output, so it is not a storage location. This would be a way to show a timer being used to time an event. Each complex process from level 0, shown here, expands to become a new system in a level 1 diagram. So this rectangle has expanded to become this. Notice the position of the external entity for the system. For the patch, I would suggest you do only 2 diagrams, a context level and a level 0. Place all the events as processes on the level 0 diagram, as well as any reusable methods or procedures and functions you have planned.
Do we have to use the flow diagrams you used?
You don't have to use the shapes suggested or use the diagram I used. You can even submit hand-drawn diagrams. You don't have to use complex graphic design software. You can use MS Word's shapes and drawing tools. This is a game event. Here we have shown the entity, the player, the event, a game event, and the data storage, and used arrows to show the data flow. In the rectangle, you could list things like what types of game can be played, or the different process for the event, or say that you're going to use arrays, or you could just leave it blank. There is enough information given by the labels on the arrows to clearly see the data flow for this event. Here is your task for today. Draw up a class diagram for a player object, which must store the player's username and 2 totals. One total is for the number of questions attempted. The other is for the number of answers which were correct. These totals must be increased after each game has been played. The object must be able to return the username for messages and a number that will be shown to the player as the percentage of questions correctly answered. Don't forget to say what is private and what is public. That's all for today. Have fun with your class diagrams and data flow diagrams. See you soon.